what's going to be on the exam. So certainly it's closed book, closed notes. You bring the A4 size handwritten notes, double-sided. You should bring a calculator, okay, and your note sheet. Exam is just in class and no computer, no cell phone, and also no that meta glasses. Okay, cannot use that. No. And also, one thing to mention, if tomorrow you found, oh, I forgot to bring a calculator. Last exam, I have somebody write down, I forgot no calculator, so always the last step, just to stop there. We always have the solution. You come here, you can use the cell phone or use my computer calculator. And also, if you forget to bring the cheat sheet, let me know, okay? Last time, 1 year ago, I have one. So you come like 8 a.m. class and come pick up back and attend the 9 a.m. quiz. Or, I can give you, like your group, maybe give you a makeup in my office. It's always have a solution. I do have students write down, I forgot to bring my cheat sheet. That's all I can do. You should communicate with me. There's always one solution. Okay, so I required, you must bring calculator, must bring your note. But in case at that day you forget, it happened, it's still not the end of the world, just let me know. Okay. So what will be covered in the exam? For chapter 2, probability, we talk about the linear function of random variables. Chapter 4, distributions. Last exam, we already tested binomial distribution, so no binomial distribution. But since binomial, hypergeometric, they are quite close. You maybe have the like true or false questions. Certainly you understand they are different and why they are different. And the normal, exponential, and uniform distribution. For probability plots, you only need to know if give you 2 plots, what's the meaning? Does that means the data normal or not normal? Okay. Central limit theorem, that's our foundation of confidence interval and hypothesis testing. Confidence interval, we only focus on 2-sided confidence interval for population mean and proportion. Is a larger sample or small sample? So we will talk about this in detail. Hypothesis testing, we have a lot more content. From the one sample, here is the one sample for population mean and one sample for population proportion. Population mean also have the larger sample versus the small sample. And more recently, we had these ones, the difference between 2 means is a larger sample or small sample, so it's z-test or t-test. Another 2-sample case, the paired data. The paired data, you can just write down, calculate the difference, and then it becomes the single, just a 1 sample t-test. And today we completed the test with categorical data, chi-square test. So they always have the one problem on chi-square test. Type 1, type 2 errors, that's only appear on the concept, multiple choice or true or false. So in the textbook, it's a little deeper on how to calculate the power of the test, like the type 2 error probability. So we are not going to calculate that because that's too complicated. You need to know the true population mean, and then you know what's the probability you make type 2 error. But for type 1 error, the probability is alpha. Okay, you make type 1 error. Question.
So you understand the type 1 errors are on the midterm, and the type 2 errors are not covered in class, but they're in the textbook.
Yeah, you need to know the definition, but you don't need to know how to calculate the probability of type 2 error. Yeah, I gave a situation, you know, oh, this is type 2 error, this is no error, this is type 1 error. Okay? And also, if I increase alpha, so what's the probability of type 1 error? Alpha increase, type 1 error will increase, but type 2 error will decrease. So you know the relationship. So next, I just go through the summary. So I have 3 files here. That's the formulas or the concepts you put will appear in the test. First one, the distributions. This one. So commonly used distributions, just since binomial, we already tested before, so no specific question on binomial distribution. But I just list here is like a complete summary for the distribution. No binomial on the test. Hypergeometric, so you know the formula, but I don't expect you to manually calculate because that's too large, you cannot do that. So hypergeometric, you know it's different from binomial, and also you know what's the range of x. Okay, this is dynamic, so you know what's the range of x, and also the average. Okay. So this formula is complicated on standard deviation, so we are not going to test on that. So you also
Wait, sorry to clarify, you're not going to test on it?
on sigma squared. Yeah. So you only need to know the formula, the
Just
mean.
the formula,
Yeah.
we're not going to be calculating.
Yes. And for this one, you know the formula, but no calculation, really calculation. And certainly give you a problem, you know, you can tell this is follow hypergeometric distribution. And what's the parameters? Okay? What is the n means, what r means, what is this lowercase n means? And the Poisson distribution, it's only one parameter, lambda. So lambda is the rate. So you certainly need this formula to solve the problem, and it's solvable. Okay? I gave you x, gave you lambda. You should be able to tell what's the probability. Okay? And also you know the mean and the variance. The difficult part sometimes is lambda. I may give you lambda is per hour. So per hour, 10 people go to the ATM, but I ask, so for the last 3 hours. So you need lambda will be per 3 hours. So how you define that lambda? That's the sometimes the difficult part. Normal distribution, we used a lot. Certainly, if you can easily to remember the empirical rule, that can help you speed up. Okay? Some of the multiple choice problems, you can use this quickly solve it. But certainly you check the table, take more time, you also can solve it. So for the normal distribution, you certainly need to know how to check the table to solve for the probability problem. And the exponential distribution is highly related to Poisson distribution. If the process Poisson, the time between the event happened follow exponential distribution. So they share the same lambda. Lambda also the rate per time unit and how many times happened. But exponential talk about this x is a continuous one, talk about the time. So we used more often is this CDF, cumulative distribution function. Okay? And also you need to know what's the mean, what's the standard deviation. For lack of memory property, you remember our example. So if you wait, you already wait 10 minutes, and then what's the probability that happened in the next minute? So it has nothing to do with how long you wait. You count the time just from now, you started counting until it happened. That's the x. Okay? So that's the meaning of lack of memory. Uniform, that's the simplest distribution. Certainly you need to know the density function and the mean and the standard deviation or the variance. Okay? So the formulas should be on your note sheet. And then we talk about the linear function of random variables. So linear function, so three scenarios. First, there's no requirement on x or all these variables. The mean, the linear function of the mean is the individual mean, the linear function of the individual mean. And a little further, the variance you can add them together, but the requirement is all these variables should be independent. Okay? So that is why we talk about all the samples should be simple random sample. That's guarantee you pick up each one, they independent from each other. Okay? Because you need to add all these variables together. So last one, if the distribution follow normal distribution, and then the linear function of this normal distribution variables should also follow normal distribution. So if I ask both from exponential distribution, you add together is not exponential anymore. Okay? Although you know the mean, you know the variance, but the distribution changed. If I have exponential distribution, more than 30 of them add together, we can know the mean, we can know the variance. We also know it's turned out based on central limit theorem, it should follow normal distribution. Okay. So that's the linear function of random variables.
Question?
Yes.
When you say,
No, linear combination is just a linear function of these random variables. You can plus, minus, that's a linear function.
Does that apply to the means? I don't think so, right?
The linear function applied to the mean. See, the mean, your linear function's mean is the individual mean's linear function.
What I'm asking is if you have a data set that's like following the normal distribution and you combine it with another data set
Yes.
to form a sum, is that also going to form a normal distribution?
It depends on which type. If it's a linear operation, you add together or you subtract the linear function, that's still follow normal distribution. If it's nonlinear, you have to do the simulation like one of our lab. For that, that's a nonlinear function, but it's turned out still normal. But it's not the case always. But the linear combination, linear function is always normal. So central limit theorem, we know the X bar follow normal distribution if sample size larger than 30. And also, you add all these more than 30 together, it's still follow normal distribution. So that's why if it's all exponential or uniform, you add together, it's as long as sample size larger than 30, add together also follow normal distribution. So confidence intervals, we only work on confidence intervals two-sided. So that's why it's always z alpha over 2. Okay? The z value, z alpha over 2. If it's a larger sample, you know the population standard deviation, you use the sigma. Okay? If larger sample, you do not know, you use the sample standard deviation. If small sample, population is normal, you know sigma, you still use the z. That's more accurate. Okay? But most of the times you don't know, unknown sigma, you use t. Okay? You use t is always say alpha over 2, and also you need to know the degree of freedom. So this is for the confidence interval on the mean. And confidence interval on proportion. So first thing, the p hat always, okay, p hat is the sample proportion. P tilde is not the sample proportion, it's the adjusted one. Okay? It only works when we calculate confidence interval. We want a more accurate result, and also is better for the small sample size. So just make sure p tilde only appeared once when we talk about confidence interval. So for hypothesis testing, we always p hat. So that's x over n. So we need to know, if you use this formula p hat, we make sure it's a larger sample. So use np larger than 10 and 1 minus p larger than 10. So always we need to test the sample size because it's popularly used. So this is how you got the sample size. It tell you the confidence level, tell you the margin plus minus the margin I want. You always can find out sample size. Okay? Make sure if you do not know have no idea about the proportion, you just use 0.5. So last time I have student write a note to me, see, I know the equation, and he copied the equation, said, but you didn't tell me what's the P0. Okay? If no P0, that's 0.5. So this is the confidence interval part. So hypothesis testing is a one sample or two samples. Okay? So 3 steps. First, you know what's very first, define the parameter of interest. So always read it twice to see. Hypothesis testing usually like 20 points. So do not lose the whole point. Every time I have like 3 or 4 students, I ask for proportion, but he just used all the way down. He thought that it was the hypothesis on the mean. Okay? So for example, we had see this, so I already have some quiz solutions here. So previous quiz, say 100 household, 84 had high-speed internet. I ask for, can you conclude more than 80% household have high-speed internet? So obviously, I'm asking about the proportion. I have some students thinking about x equal to 84, and then try to prove this x value, the mean is larger than 80. It becomes totally wrong. Okay? So read twice to see what's the interest, what's the parameter. It's about the mean or it's about proportion. Okay? You see the proportion, or sometimes I also give let P be the true proportion. Okay? So you really need to know this one. That's the common error part, common problem. And once you know that, the hypothesis, H naught always have the equal sign. Okay? Alternative, always no equal sign. And then you assume H naught equal is true, you calculate test statistic. Is a z-test or t-test. So I list a table here for, say, one sample test. If it's larger sample, okay, you always the z-test. Okay, for the population mean, it's always z-test. For the small sample, it's normal distribution. If you know sigma, it's also z-test. Small sample, normal distribution. If you do not know sigma, that's t-test. So you also need to know, sometimes people just choose the different. Yeah, it should be t-test, they use the z-test. Okay? That's the problem. For proportion, always z-test, and then the standard error part. This is p0, not p hat. That's another common error. Okay? So you claim the p equal to 0.8. Now you calculate the standard error should based on you claimed in the non-hypothesis. It's not the p hat from the sample. Another thing always missing, people forget to check the NP0 should be larger than 10. It's, see, also the one you claimed, not NP hat, NP0. Okay? NP hat only appears on the confidence interval part if you check. So this is NP0. And for here have the rejection region and the p-value. It's all depend on your alternative hypothesis. If two-sided not equal to, you use alpha over 2, and the p-value you need to multiply 2. If you're only one-sided, you're not sure it's larger than or smaller than, you look at alternative hypothesis. If it's larger than, you look at upper tail. If it's smaller than, you look at the negative side, the lower tail. Okay? So I list all here. And for the two-sample test, certainly it's easy if both are larger sample, that's just z-test. This is also workable. You can manually find out, solve these ones. Okay? But if it's a small sample, normal distribution, we use t-test. So I'm not testing you to manually to calculate this. So most likely, like the practical exam, I gave you the output from Excel. You need to interpret. Okay? You know how to, what's the meaning of each value and how to answer the questions based on Excel output. Okay. Another one, if it's a paired data, okay? The paired data always comes from the same observational unit, okay? You can tell the paired data is all dependent. The two samples, if it's larger, it's all larger. If it's small, it's all small, okay? And then you calculate the difference. I put the degree freedom here. I'm not expecting you don't have to put it into your formula sheet. I'm not going to ask you to calculate manually. Put here just for the completion of this, the summary. Okay? So chi-square test, certainly, the two situations you need to know and how to calculate chi-square, how to check the table. For the error part, you also know the definition. What's the meaning of type 1, type 2? What's the meaning, the power of the test? Okay. So we're done with, and also the beta, say one called alpha, the probability type 1 error, one called beta. I also have so this is some quiz solutions. You see, some you already did it in class. I may have a couple, because I don't have time in class, have the quiz, but I have as an actual exercise, have solutions here. Already post the practice exam. So if you have any questions, you can shoot me email. So I hope I can squeeze sometimes next week to Wednesday to answer some common questions on practice exam.